Hey, what's up, guys? The last couple weeks we've been working on our projects. We're going to start some new lessons. So who knows how long we're going to be on this remote learning kick. So we got to move on. So to this point, we've dealt with one variable, right? And mostly we focused on the quantitative variables. Today, we're going to start to talk about the relationships between two quantitative variables. Again, your projects, you involved one variable, whatever it is your topic was. And now we're going to say how two variables are related. All right, so we're going to start with what those variables are actually called. So in algebra, you normally hear about independent and dependent variables. In statistics, we call them something different. All right, so we have our response variable, and the response variable, it just measures the outcome of a study. And that's essentially like your independent variable. Then we have what's called our explanatory variable. And what the explanatory variable does is it helps us make predictions. So it may help predict or explain changes in a response variable. All right, so explanatory, obviously, that means it's going to kind of explain the relationship of the response variable. And this is basically our dependent variable. Yeah. So we call them response because the response variable, we're going to get a nice response. And the explanatory is going to explain what's going on. What we're going to generally use for this is something called a scatter plot. You've probably seen that before. Scatter plot is simply a graph that shows the relationship between the two quantitative variables measured on the same individuals. All right. So basically, if we're talking about people, our two variables are going to be both on that same person. If we're talking about cars, if we're talking about whatever it is we're talking about, we're going to use a scatter plot to measure that. All right. So some examples, we'll see some scatter plots later actually, but now we're going to kind of move on to what we're going to use to describe a scatter plot. And there are four things we're really going to focus on when we're describing a scatter plot. And we're going to use an acronym for that. That acronym is going to be DOFS. And in DOFS, the D stands for direction. The O stands for outliers. The F stands for form. And the S stands for strength. All right, so direction is basically what direction our data appears to be going in. And we're going to be talking about the association between the two variables with our direction. And our three different possibilities are going to be a positive association, a negative association, or no association. All right, and I'll quickly flip to some examples. So these are some examples of scatter plots. So we have a positive association here. And notice that as your x is increasing, your y is also increasing as well. That's the pattern of our data, right? It appears if we were to make a line of best fit, and we'll get into that in future sections. You've probably heard of that term before. We're going to kind of use a better term for it, but our data is increasing here, so that's a positive association. Over here, our data appears to be as x is increasing, our y is decreasing. So this is a negative association for our direction. And here, it seems completely arbitrary, so this would be no association. So these would be our three different ways of describing the direction of a scatter plot. All right, outliers. We've talked about outliers before. They're a little bit different in terms of a scatter plot. But it's the same basic premise. It's points that are far from the overall pattern of the graph or data. Overall, I don't think that's a word. So that's basically if I were to have, one point that's really far away from the general pattern. So once we get into our lines of best fit, you'll see that there's maybe one point that's way far away from that line, and that would be an outlier. All right, form. Now the form is just, is our pattern linear or is it nonlinear? So if it's linear, it's making a line. If it's nonlinear, it's not making a line. It's that simple. And strength is just weak, moderate, or strong. So how close to the form is it? Is it a strong linear relationship, meaning that they're very close to making a line? And if you look, this is pretty strong linear association, strong positive linear association. And this is, I'd say, moderate to strong linear negative association. And since this has no association, you're not really going to describe the strength at all. All right. So these are the four things we're going to be using to describe the relationships between two quantitative variables. Now let's do a few examples. All right, so I'm going to pull up some data here, and I'm going to show you how to do this on your calculator. Now, you guys, if you reboot your Chromebooks, there should be an 84, a more updated version of this calculator on your desktop somewhere. So we're going to put in our data like we have before, and I'm going to go to the stat function and edit. And I'm just going to type in, and this is what we're going to be comparing, is a student's quiz average throughout the year and their final exam grade. So we're going to put the first column in L1 and the second column in L2. So hopefully you do this as you're watching. That way you actually know what you're doing when we get to doing the examples. And be careful about getting it correct. 92.1, 70.7. I'm just going to put all my data in here. A little tedious, but much faster than doing any of this by hand. And now I'll put this, hopefully it goes a little bit quicker. no decimals. All right, we're going to get people who did terrible on their final exam. All right, so now I have my data in. So now I'm going to make a scatter plot. So what we first need to do is go to second and then the y equals button. And we need to turn the stat plot on. So you should get to this screen after you hit second y equals. And then I'm going to hit enter. And now I want to turn this on. And this first option right here, that first option is going to give us a scatter plot. All right, we have our x is the L1 and the y is L2, just like we want. Now, I need to set the window here. So that's basically what is my graph going to show. So if I hit window, now I have to look at my data. And I see that these are all numbers essentially between 0 and 100. So I'm going to go from 0 to 100 here. And that's the x min and the x max. That's what your range is for your x values. Scale is how much you want to go up by. We'll just say 5, I guess. Does not really matter. The y also are between 0 and 100, and will also go up by 5s. And then I hit graph, and you can see that this is my scatter plot right here. Now, I don't particularly love that window because everything is kind of crunched over the right. So I'm going to change this since my lowest quiz average looks to be in the 60s. Let's just start at 50 and go to 100. And let's start this at 30 and go to 100. And that just gives us a smaller window here. And we can see this relationship a little bit better. All right, so we have our scatter plot here. So now we need to figure out our description. So if you were to look, this data is going upwards as x is increasing, y is increasing as well. So this is going to have a positive association for our direction. All right, outliers, I don't think there's anything particularly far away, maybe this point right here. So I could go either way on this point, and we can check what that is by hitting the trace key and then just arrowing over, and it arrows between all the points. So we can see that that point, once I get to it, is this 66.2, 65. All right, so that I could go either way. You could say that's an outlier, you could say it's not, whatever, I'd be fine with either. Our form, this looks to be pretty linear. It's not great, so I would say in terms of strength, this is a moderate linear positive association with either none or one outliers. Okay, so that's your first example. Let's try another one. And this was a bunch of people were polled on their age and how many streaming subscriptions they have. So we're going to do the same thing in here. We're going to go into edit. Remember, if you want to delete your data, hit clear, highlight the header, and then hit clear and enter, and it'll clear that data. This should be a lot quicker to put in. There's less of it. So this first column is the age of the people. And the second column is how many streaming subscriptions they have. All right, again, we're going to go stat. Oops, sorry, no, we already have that. Our stat plot's already on. So we're just going to go to the window, and we're going from 0 to about, our highest age is 72, so I'll go to 90. I'll keep it at 5. Our Y-min goes from 0 to 6. So just to give me some space, I'll go -2 to 10. And let's say we're going up by 1s here. All right, and then I'm going to hit graph. And what we can see here is our direction is clearly negative. So what that means is as the age goes up, the number of streaming subscriptions goes down. So this is going to be a negative association. And then our outliers, I don't really think there is, because your line would probably go about here. So I'd say that there are no outliers. All right, our form, again, this is linear. All right, we have pretty decent straight line, and this would be, I would guess, moderate, maybe to strong. So a moderate, moderate, moderate negative linear association with no outliers. All right, so this is how we describe two variable relationships using these scatter plots. All right, you're going to have an assignment posted. Please do it, and that will be due on Wednesday. Hope everyone had a nice spring break and enjoy this first week back to remote learning.